If we start with a circle and 1 point, and you see that there's only one region inside the circle. 2 points, 2 regions within the circle. 3 points, 1, 2, 3, 4 regions within the circles. If you have 4 points,
1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Right. So in this case, we have 1 point, 1 region. 2 points, 2 regions. 3 points, 4 regions. 4 points, 8 regions. 5 points, 16 regions.
So the question is, when we have 6 points, how many regions within the circle? So how many regions here?
Pause the video now if you wish to solve it. Keep watching the video once ready.
In order to answer this question, the simplest way to do is just draw it and count, and we'll get the answer directly. But if you look at the so-called pattern, you see that 1, 2, 4, 8, 16, and the next one, do you think that is 32? Yes, I believe many of you think that that is 32. Let's draw it out and count. The assumption that we have to make is this is not allowed. 1, 2, 3, 4, 5, 6. We draw it as big as possible so that it's easy for calculation. Now we are going to do the counting now. Okay, so we need to do a systematic way. We count the outer one.
1, 2, 3, 4, 5, 6, 8, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, now 25, 26, 27, 28, 29, 30, and
the last one, 31. So it is 31, not 32. So now you have 31 regions. But the question is, why is 31 not 32? We are going to prove it in general case. What happens when it is equals to n points? And why is the answer look like it is 32? We need to know Euler's formula that stated that E plus 2 equals to V plus F. We can count the number of edges. Number of edges, and this is number of the vertices. And this is the number of faces. Okay? Let's say, for example, in this case, we have E is equals to 1, 2, 3, 4, 5, 6. You have 6 edges. So E equals to 6. The V is equals to, V is the intersecting point, that's 1, 2, 3, 4, 5. V equals to 5. F is the number of faces, also we call a number of regions. So there is 1 region here, 2, and there's outer region, 3. So F equals to 3. So when we sub in, the left hand side is equals to E plus 2, and equals to 6 plus 2. That is equals to 8. And the right hand side is equals to V plus F is equals to 5 plus 3 and is equals to 8. This is only one example, but it can be proved that this is always true. So let's say in that case n equals to 4. You have 4 points here. You will have exactly one intersection in the middle. We are able to count what is E and what is V. And therefore, using this formula, we are able to find out what is F. V is the number of vertices. In this case, we already have 1, 2, 3, 4 at the beginning. So this is N. However, you will have some intersection in between. In this case, you see that there is only 1 here. But when n increases, the number of intersection also increases. What is the formula? Now you notice that for any a point intersection is actually come from here. Any 4 points on the circumference will form a quadrilateral with 2 diagonals. And these 2 diagonals will have an intersection. Any 4 points will give you an intersection. And any intersection is come out from the 4. And that's why this is not allowed. Otherwise, this is not true. The number of intersections inside will be equal to n choose 4. Now we are going to count the number of edges here. First of all, these are the edges. N equals to 4, you already have these 4 edges on the circumference. So that will be contribute n. For any 2 points, you join by an edge. So there will be n choose 2 of them. And you have 1, 2, 3, 4, 5, 6 initially. However, let's say initially have these 2 lines, but then they intersect. Instead of 2 lines, it becomes 4 lines. Because for each intersection, you will break each line segment into 2. For any intersection, the number of edges will increase by 2. It increased by 2 times n choose 4 edges. So this is number of edges.
N equals to 4, V will equal to 1, 2, 3, 4, 5. That is 5. And when you sub in N, that is 4. 4 choose 4 is 1. That's correct. And E, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is 12. In this case, this is 4. N choose 2, 4 choose 2. And 2 of 4 choose 4. And this is 4. And this is also equal to 12.
This is to verify that the formula is correct. From the Euler's formula, F will equal to E plus 2 minus V, whereby E equals to n plus n choose 2 plus 2 of n choose 4. That's E. Plus 2 minus V is equals to n plus n choose 4. N minus n will cancel off. You have n choose 2 and plus 2 of n choose 4 minus n choose 4. This is n choose 4. And you have a 2. When n equals to 4, F will equal to 2 plus n choose 2 plus n choose 4. That is 2 plus 6 plus 1. That is 9. 9, not 8. Why is it so? Because it calculates the outer regions.
In this case, you will calculate 1, 2, 3, 4, 5, 6, 7, 8, and 9. That's why you will have 2 here.
The number of regions within the circle will be equal to 1 plus n choose 2 plus n choose 4. N equals 1.
F will equal to 1 plus 1 choose 2 plus 1 choose 4. That will be 0 and this is 1. N equals to 2. F will equal to 1 choose 2 choose 2, 2 choose 4. And that is equals to 2. N equals to 3. F will equals to 3 choose 2 and 3 choose 4. That is equals to 3 and 4. N equals to 4. 1 plus 4 choose 2 and 4 choose 4. That is 1 plus 6 plus 1. That is 8. N equals to 5. F will equals to 1 plus 5 choose 2, 5 choose 4. That is equals to 1 plus 10 plus 5. That is 16. N equals to 6. That is 1 plus 6 choose 2 and 6 choose 4. That is equals to 1 plus 15 plus 15. And that is 31. Log 32.
In this case, we see that this is 2, 0, 2, 1, 2, 2, 2, 3, and 2, 4. And it doesn't suggest anything that it must be 2, 5. Not necessary.
And why this is so nice that this is 2 to the power of n? It is because of Pascal triangle. We know that the sum here,
This is 1 plus 1 equals to 2, and this is equals to 4, this is equals to 8, this is equals to 16, 32, and 64. Okay. What happened for this one?
1 we can treat it as n choose 0. So in this case, we are counting the alternate number.
When n equals to 1, we are taking only the first number. When n equals to 2, we are taking the first number and the third number. When n equals to 3, we are counting this number. When n equals to 4, we are counting this number. When n equals to 5, we are counting this number. When n equals to 6, we are counting only the first 3 alternate number, not including this one. And we know that the sum of alternate number in each of the row will be exactly half of the sum. That's why we have the following answer. There's one video that I made last year, similar to this. I'll put the link of the video at the description. You may go and check it out.